So going back to the burger analogy for protein synthesis, we can also use this when thinking about different mutations. So you'll remember I had this transcript, this RNA transcript that was transcribed from our DNA cookbook. Now, our DNA cookbook could contain a typo. It's very possible. So same thing can happen in our cells. Our DNA can already have existing typos that we've inherited from our parents, right? So that would be some kind of hereditary genetic mutation, which are obviously pretty common. Now you can also have an error or a typo occur in your RNA transcript, okay? So if we have a typo in the RNA transcript, that means as our DNA was being transcribed into RNA, something went wrong, right? One of the base pairs just wasn't paired up correctly, and that can lead to a mutation. So in this case, we could say an equivalent would be, what if I accidentally put, instead of 4 buns, I had written down 5 buns, okay? If I had written 5 buns instead, that would just mean I had some extra buns. So it wouldn't be a terrible case. And so sometimes that is what happens. Mutations can just be relatively neutral, meaning they don't really have a positive or a negative effect. So that one wouldn't be too big of a deal. Now let's say, and whenever I was actually making my sauce for my burger, which is supposed to contain mayo, I grabbed the wrong jar and I got out marshmallow fluff. And I actually started to use that marshmallow fluff and put it onto my sandwich. This would be a problem, right? We don't want that to happen. So if I had noticed marshmallow fluff was sitting on the counter instead of the mayo, then I would remove that from the situation and put the correct ingredient in place, right? So I could remove that marshmallow fluff and put instead that mayo. This would be the case of DNA repair. So if in your DNA sequence there is a specific mutation that has come up as an effect basically from that RNA transcription taking place, if that's the case and you have one of these kind of typos, it can be taken care of. And so in this case, it's going to be essentially deleted by a process called excision. So specific enzymes will come in, remove that piece of DNA, and then your DNA polymerase and your ligase can go back through and just go ahead and insert what needed to go there. So this is the process. It does have to happen very quickly. Otherwise, that DNA is just going to be transcribed. You're going to get your RNA transcript. Even if there are some errors, it's going to move along pretty quickly. So there's a time-sensitive frame that this would need to happen, similar to my example. So if I was making this and I didn't switch my mayo out, and now I've actually put the marshmallow fluff onto my burger bun, and I've assembled my burger, and I go to take a bite, it's a little too late, right? I've already made that burger, that marshmallow fluff has soaked into my bun, could be a problem. So that's what we want to think about with our mutations as well. So I just wanted to use that as an example. Basically, those typos a lot of times are going to happen during the transcription step. So it's very common for that to happen, and just like whenever we write something down, we may make a mistake. Sometimes it has a negative effect, sometimes it may have a positive effect, and sometimes it's completely neutral and has no effect on the overall outcome of the protein, just like genetic mutations. So hopefully this analogy has helped you to once again understand microbial genetics and microbial genetic mutations.